Okay, in the name of God, the compassionate, the merciful. So today, given the time in Bergen, and you've got to go around, thank you very much for being around. There was another guy, had a Scottish name, who said that he would be able to join us from this week, but he just didn't show up. I think his name is Daniel. Now from the university or from, I think he was, yes, he is a student here, I believe. Huh. But yeah, there's a fair amount of people called that. Right, and he has a Scottish name, so it matches something. Yeah. Now, what else? So we are still missing Mikhail, though, right? Do you have any?
He's coming, coming from Oslo to Bergen tonight.
Ah, I see. Right, he said that. I think that he would be traveling. Yes. Okay. Okay. So we're not recording for no one. At least there is Mikhail to watch.
Yeah, and just we can go back later.
Right. Yeah, sure.
You have all the people at home.
Okay.
Yeah.
Okay. Yeah. So me trying different possibilities for teaching you guys who are top notch. I thought that it probably is best to just go through this chapter by showing you the thing live in Visual Studio. So here is the session that we're going to work in. These are old, but then we'll go through the files at 1 minute. At some point, we'll also try to look into the book, because there is something I want to show to you from there. And that would be pretty much our session. Now, please, Sam.
I have apparently much worse eyesight than I did.
Oh,
increase the font.
Oh, absolutely, absolutely. Yes, but it doesn't. Okay, I think I know what's happening.
Under view.
Just a moment.
Oh, there we go. Oh, that's a bit. Yeah.
Is it just a bit better, or is it?
No, that's a lot better. You probably didn't move it
too much.
It's slightly smaller. Yeah, that's good.
That's also good. Okay.
Yeah. It's just that I don't have to split that.
Okay, good. Good. Now let me see. Let me grab more space.
So weird. After I started using glasses, my eyesight just went off a cliff.
My one is also going down. It's been some time since I realized that, but I never had the time to help it. Anyway, so this chapter 3, is kind of your beginning of exploration of the real thesis of the book, the type. Oh, there's a type of you. Type, refine, define, refine. The idea is that you work out the types, then you add definitions, then you perform things like case split and expression search, and you lemma things out. These are all done using the great support of this language, Idris, as we're going to see. Now, so suppose that we want to have a function that essentially maps length to a list of strings to get their length, their individual lengths. So and this is me being quick on you guys, because you are Haskellers, you know what the map function does. Now let's suppose that we don't know that there is a map function for lists, and we want to do it manually, right? excuse me for being so rudimentary. Now, so let's follow the instructions of TPD. We have a type for it, so all lengths is something that takes a list of strings and returns a list of naturals, right? Now, first thing to do afterwards is that I'm going to click here, double click here, and you see that lamp showing up here. Then I click on that and I say add clause. And here we go. Idris can figure out that, okay, this function takes an argument and, well, it does something with it. And that's the reason why there is a hole to the right of the equal sign, right? Now you say that, this is very important. This was the time that I should have told you the joke on Jesus saves, so that you know that it's a very strict rule that if you want to get that intelligent support, then you have to save everything step by step, right? Now, so this is it. You now have a body. Now, just to show you, where's my, right? Maybe I should do that later. Then you can do certain things. So, for example, you can, if you try to inspect the type of the hole, right, just by hovering on it, you realize that it says that provided that STRs is a list of strings, I know that that whole thing is a list of naturals. Right? Now, so you have that typing information at hand, so that you can draw those. Draw some sort of conclusion about what you're doing. Now, I imagine that you guys being students you're not from the logic group, right? The rest of you knows that this thing that you were seeing, I said, provided that STRs is a list of strings, we can conclude that. So there is a horizontal line above which there is the assumptions and below which there is the conclusion. This is typical of logic, right? You're familiar with that, right? Even though you're not a logic group student.
I want to make them one.
Yeah, okay, well, you can't get numbers. Now, so that's how to get that help. Then here comes it begins to do even more interesting things. Now, that being a list of strings, and you know that list has a couple of type constructors, right? What you can do is to ask Idris to do a case split for you according to the type constructors of that top type that you see for the STRs. That gives you automatically two cases according to the type constructors of list. Right? Now you can save that, and that's important to save. Then you can take a look at how it drives typing information for the second O now. So if you pay attention, it says that X is a string, X is a list of strings, and as a result, I can conclude, I being Idris, that the second whole is a list of naturals, right? Now, it's time to do some good work here. Now, this is something that I shouldn't show you at this point, but the idea is that, okay, you as a programmer now know that the result of this one should be empty list, right? And the result of this one should be link of X and then all length of X's, right? Now I think I have an extra pair of parentheses here. That's okay. So that's your function, and let me load. Right, so then if I just say that I want to do all lengths of this in any test, we get the list of lengths as a result. Now, but the magic of Idris doesn't stop there. So I'm going to show you a bit more actually. That's precise. But before I do that, here is what I like to do, and this is just me, my personal preference. I like to align these things according to their things above them. So I do this, so that to me they better aligned vision. This is how I do it. Right. So just to recap on what we did, we asked Idris, after providing the type for it, to give us a clause. Then we perform case splits on the clause on a variable in that clause, and then we did some sort of expression search. We do that. Right. Okay. I actually missed something here. So just right. Let's bless you. Let's say that on our way we stopped at this point with instead. Right, and this is giving it better names. So the thing is that we still have a home here, right? Now let's just reload. Okay, and then let's just say that we do run this. Interestingly enough, given that we have only provided the full instruction for the first option, and we have a home here, we only perform one length calculation for the head of the input list thus far. The output that you get is 5 : the whole name, right? And you see that there is also coloration with regards to the holes having different colors to the real thing, right? Now, this is I would say that when your project grows, this is a very helping step. You can it helps you concentrate on one thing at a time. It's a great tool.
I believe if you go to programs, you can also have a overview
of what?
If you okay, never mind. This is what that way works.
Okay.
Sometimes, like in INF, you can see the list of open holes.
Right. It's I haven't seen that in Visual Studio. No, in Visual Studio. In Visual Studio, when you get problems, you usually get problems that Visual Studio is facing, not the actor compilers. Yeah, but I mean, by all means, just teach me more than
Yeah.
what I'm teaching you.
I mean, I got it up here for you.
Right, yeah. Okay. Right. So the other thing is that even though we now have a version that has a hole in it, if we ask Idris for the totality of this function, as I'm now going to do, Idris tells us that this is total. That is because we have cases for both the type constructors of the top level type, which is list, right? So that's the meaning of totality, as you have all studied, I guess. Right. The other thing is that, like everything in Visual Studio, you can look up the definition of list. You get a short version here by pressing Control and hovering over it, and if you click on it, you will get to the file that actually does the job. This is the file. Now we're going to get into how to do data types and all that pretty quickly, especially because you guys are so good, so I can just flash through. But just have a look for the moment, and we'll get our hands dirty later. Right. So now, so you can do pretty much the same thing for a function that takes a natural number and tells us whether or not the number is even. So so a natural number it takes, a Boolean it returns. Oh, and by the way, if you don't have a line after the type definition, then the body that Idris will, the body that Visual Studio will produce would be tucked just next to the type definition. So you would want to, when you save, make sure that you give it one extra line so that the body that it generates goes to the line below, right? So I'm going to add clause, and then I'm going to k-split on k. So I need to save and then do the k-split. So this is what I get, and the reason is that if I if I look at the documentation of NAT, I get to see that there are two type constructors here. There is Z, which has this syntactic sugar, the letter 0, and there is S, which is for the successor. Now, I guess that you guys, sorry again, maybe I should exclude you, but you guys, being logic people, you know about the piano arithmetics and all that, right? Yes. So
basically, yeah.
Yeah, right. So that's how the natural numbers are essentially built. You have a 0, and then you keep successing on it so that you generate all the natural numbers. Now that is by knowing this, and by knowing that this is a total data type, Idris can figure out that there are only two cases here, right? It's either this is 0 or it's a successor of something for a k that is natural again, right? Now, then we perform a k-split, so let me just make sure that things are saved, right? Oh, I'm sorry, that was I was one step ahead. Then right, so how do we do this? Let's say that we want to do it manually. We would say that this is true. Let's say you want to do this recursively. So you would do as if you want to do a not on is even of k, right? So that's one possibility, and so you can test this, and you can ask for its totality from Idris, or what you can do is that you can do it by mutual recursion. How many of you are familiar with the concept of mutual recursion? No? Okay, so mutual recursion is when you have more than one function that perform recursive calls to one another, and so we're going to see one example of that now. So you know, the idea is that in order to check something being even, you have the base cases, and for the rest, so if something is even, then the one minus that thing should be odd, right? And if you want to check whether something is odd, you have the base case, but if it's not the base case, then one minus that thing should be even, right? So these kind of get back and forth. They play this ping pong, right? And the way to do that is this in Idris. Let me just so you put a mutual keyword at the top, and you indent one level. And by the way, I don't know whether I told you ever that these indentation things are important in Idris. So be aware of that. And then, so you give the types, and you work out the cases. Is even for 0 is true. Is odd for 0 is false. Is even of the successor of something is odd of that thing. In the same fashion, is even of the successor of something is even of that, right? So this is the ping pong between is even and is odd. And you can also look up the totality of this. So I'm not going to show it to you now. You do it yourself. Now, here is where you begin to touch the surface of dependent typing. Now, I told you at the very beginning that there are these things about you know, numbers entering into the world of type systems, and the fact that in Idris there is no real difference between types and other values. You can have a variable in pretty much the same way that you can have a type variable. Now, and I showed you something about vectors. So here is a quick recap. Now you can have a vector of 4 integers like this, and a vector of 6 integers, and you see that we have the part of the type information is the dimension, which is no longer a type itself. It's only a natural number, right? So if you hover on it, no, you don't. Okay, right. So yeah, and then you can do things like, so if you add these things together, you concatenate them together, you get something of the addition of the 2 dimensions, right? And In fact, let me just maybe help you with something else. Demonstrate something. Oh. Jesus. Right, so if I do and if I want to have a type of that, you get to see that the dimension is actually embedded in the typing of this thing. Right? Now, with that in mind, let us suppose that we want to perform a TDD for the same mapping of the lengths function, but this time to vectors. Now, I'm now going to delete these. Just comment them out. Oh, sorry. Now, the first thing to do in TDD is to work out the typing. So our all lengths function is going to take a vector and return a vector. And it's important, the first thing to notice is that, you know, these dimensions, they are the same. So it takes a vector of length n and it returns a vector of length n. Right? Now, before I go through that, I am going to ask News to give us his joke of the day.
So there was this bartender working at this bar,
Okay.
and suddenly a gorilla came.
Okay.
And the gorilla came up to the bar, wanted to order a beer.
Right.
So the bartender thought to himself, hang on, this is a gorilla. He doesn't know how much a beer costs. So the bartender tells the gorilla a beer costs 200 kroners. So
I don't know either,
yeah.
but I'm not a gorilla. Okay. Okay.
So the gorilla pays, takes the beer and sits down, and the bartender just keeps staring at the gorilla, wondering why a gorilla is in this bar. So the gorilla asks, bartender, why are you staring so much at me? I'm wondering why there's a gorilla in my bar. And he says, the gorilla answers, probably because the beer costs 200 kroners. I said it wrong.
Okay. Okay.
The conclusion, the partner was supposed to say, I have never seen a gorilla before in this bar.
Okay.
And the gorilla says, that's because the beer is so expensive.
Right. Okay. 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 Well, that would have made it yeah, slightly more complicated. But I'm sure it would have not caused us to laugh as much as we laughed when you say, oh, I said it wrong. So that could have been a good strategy too, you know, good storytelling strategy. Yeah, by the way, storytelling is actually a very serious topic to me.
Yeah.
It's, I recently wrote something, these card decks about storytelling and all that.
It's so difficult to do it properly.
Yeah,
If
very,
you really-
very,
If you
very.
can do it well.
Yeah.
Then, yeah,
I have to say that you're either a natural or not.
yeah, I think it can be taught to us.
But you can improve, and that is the hope that led me to purchasing the context, right? So there are techniques that you can improve, but I would say that certain people, no matter how hard they try, they just can't do it because they're not natural. Anyway, so let's get back to work. Thank you very much. Now, so let's perform a add clause here. Right, so pretty much trivial now for you that know that Idris can do much more. Then here is oh sorry, I perform a case split on axes. By the way, these have shortcuts in yours is Vim, is it?
Yes,
Right.
well, Idris, but yeah.
Right, Emacs, okay.
They do, yes.
Right, they have shortcuts in Emacs and in Vim and all that. There used to be shortcuts in Visual Studio Code as well, but for some reason I can't find it this time. Anyway, so thus far is not new to you. What is new is this. Let us just do as the book likes to, like with these proper names. Right. Now, the next magic wand of Idris is that it can perform expression search for you. So it can guess according to the type constructors that you get on the left-hand side of the equal sign, and according to the typing information that you have given it at the very top, especially regarding the return types, the expressions that you would put to the right-hand side of your equal sign. So if I now hover on this hole, I will realize that that has to be a vector of size 0, which means that then there is no way for this to be anything other than empty list, right? An empty vector, sorry. And that is the reason why if I perform expression search on this hole, the only option that is available here is that it gives me the empty vector constructor. And you notice that the constructor for vectors, the constructors for vectors are the same as the constructors for lists, right? So that's one thing. Now, interestingly enough, you can actually perform pretty much the same thing for the other hole. Let's see that in action. But I would like to invite you before doing so to take a look at the typing information that is available. What it says is that given that word is a string and words is a vector of length len of strings, and given that n is a nat, and I'm going to tell you what that 0 to the left of n is in a minute, then I can conclude that the whole is a vector of length 1 plus len of natural, right? Now, that 0 to the left of n at the upstairs of the horizontal line is telling us that this n information is a compile time piece of information. It will be erased so that it doesn't show up at the runtime, because it's already checked at compile time, and it requires not to waste our performance and also our storage in the runtime. Right. So this is Idris having a clear understanding of what is compile time and what is not compile time. And this to me is a very dear difference between Haskell and Idris. So I come from the world of C++. I want to have full control on what is compile time and what is runtime. And in fact, I'm very greedy on making everything compile time. Right? That's why I'm teaching you C++. Now, for reasons that we'll explain that. Now let's perform a expression search here. Now, if you take a look into the expressions that it can find, you notice that all it can figure out is that there has to be, because the return type has to be a vector of size of SK, there has to be one natural const with a list of a vector of length k, and it said that okay, probably there is going to be a recursion happen, and if that recursion is to happen, probably that is using the tail of the input list, the input vector that I get, right? So I'm going to choose this one, right? And then tell it, no, you're getting that wrong. You know, it's only length of word, and then yes, you're right on the second part, right? So you see, even though there is a lot of magic going on, Idris can figure out a lot of things, you can't figure out all the logic that is in your brain, right? And the thing is that, you know, even though there is a you have a in Idris there is a search strategy for finding the expressions that can help. The thing is that this is all type derivative. So if something is not, if some piece of information is not available at the type level, then you shouldn't expect that to show up in the expression search, right? Having said that, I can't promise that you won't be disappointed ever with you know the search, right? But it's still, I enjoy this very much because it, like I said at the very beginning of these Idris sessions, you know, with TDD, you can get Idris to kind of unfold your logic for you as you go. And this is very pleasant when you're doing, you know, these kinds of developments. And proofs. And proof. Actually, I'm not going to. That's true, but I'm not going to teach you how to do proofs in Idris. Because the intention of this module is this part of the module is to prepare you for C++ template program. But having said that, we can always you know think about possibilities for next modules and things of the like, and I would be grateful if you guys would be interested, and I would ask that from Magne and all of the people that are in charge, so that we can have a follow-up and we can have you know, dream projects about how to help magicians. You know, how to help C++ template program. Yeah. Now, we having a smile. I have, or maybe some people also cast a laugh. But I would like to tell you something even funnier. But once upon a time, I wrote to this company Sea Lion. Sorry, it's not Sea Lion. It's a producer. Yeah, JetBrains. That look, I teach Idris, and I do that because I have come to understand that it helps C++ template metaprogramming a lot, and I have instructions on how to work out your logic in Idris, and then almost automatically convert that to C++ template metaprogramming. Would you be interested in helping C++ template metaprogrammers with producing the automation of that transformation? I received this extremely enthusiastic response that I am the head of, I don't know, that part of the Sea Lion project, and I will hereafter be your help man for this project. And then from that point onwards, no matter how many emails I sent to the guy to follow on, they never answer. So, well, yeah, well, probably he died. I don't know. Yes. Yeah, but the thing is that it's having said that, if you guys are up for it, we can think about setting up that transformation, and by doing so, we will also be able to do improving on the Idris side, which will then, you know,
Extract.
drop the jaws of the C++ programs. You know, it's and we will have one paper at least on this, and we will go to some of us, well, probably not me because I don't go to the US. Some of us can go to the you know, C++ conferences and show that to people and get loads of jaws dropped. Yeah, because C++ template meta programming is such an awful task, as you better see. Now, so now I actually I got to know about Idris after more than 2 decades of doing C++ template programming. So for me, that was me having the door of heaven open to me. You know? It's just because I had gone through decades of you know, pain and blood and you know, sweating and all that. Maybe. Yeah, and it suddenly opened up. Yeah. Okay, now I have a couple of questions for you. Let us say that let me just replace that. Right. Ooh. Copy paste didn't work. Almost magic. What's wrong?
Because the length is wrong.
How?
So the type requires that. So it might not be wrong, we can't know that because n for the input could be anything of any size, and so but the output is always 0.
And this specifically,
Yes,
the case for it.
correct. So you're on the right path, but the thing is that you are saying that the typing information says that the n should be the same on both sides, but here we're only providing 0, right?
Yeah.
Which means that for the rest of the sizes, we're not keeping to our promise of providing something at the same time.
Yeah.
Right. Now, I'd like to ask you to explain to me the error message that we get. I guess you know the answer because you have done actor. Right. But let's keep it to yourself. Yeah. Okay. Sure. So I like your choice of the word solve. Right. Can you explain to me what is unification? Do you know that? Are you familiar with that term?
Yes, because I remember when I did talk.
Very good.
It came up there as an error, but I remember it was something I did, but we didn't like.
Okay, yes.
And then it said, oh, can't unify these 2 things, because I did like a step, and I didn't tell it exactly what I did. But sometimes it does, it like figured it out on its own.
Yeah.
Like what I
Yeah.
I always try, the first thing I tried on every like test was auto, and sometimes it didn't work.
Right.
And
Okay.
then I had to write. I don't think it was actually. But
So do you know the meaning of the term unification? You that's all we know about unification. Do you know what unification is?
Irish.
Irish.
oh, popped it out, right?
Yeah.
Okay. Good one.
I have a friend who's Irish,
Okay.
and he only knows IRA slogans. It's not the only piece. He only knows a few Irish words.
Okay.
By being fairly often in Ireland, and they are only IRA slogans.
I don't know that.
IRA,
The
Irish Republican Army,
Irish
Republican Army.
Republican.
You know the troubles?
Yeah, IRA, okay.
It's
Yeah, one of
the loyalist, not loyalist, the other one.
Right. Yeah,
Republican.
nationalist, yeah, sure, okay, well, that's interesting. Now, let's get back to unification. James, do you know what unification is?
No,
Okay, so you want to explain?
The type checking algorithm has to go through various stages where it goes back like the way I imagine at least is it travels up a sequence tree of all the rules for the types, and then until it can get to sort of like the resolutions, which are just identities.
Yes,
And for this one, you can't unify it as
no. You're missing a significant step after the. So what?
Yeah, I try again, you have two things in like your proof tree that are like
Yeah.
not okay, right? You can't just go to the next step and prove the algorithm. So
Yeah.
it tries like to probably insert some intermediary steps, right? Or something like that.
That is true, but there is a gap between what he
Okay.
said and what you said.
Yeah.
You're absolutely right, both are absolutely right, and it's that missing thing which is you.
So you
So,
want to give the right. step.
as you doing the type checking, as you just explained, the type system is applied, the rules of the type system are applied until it simplifies everything to the level where it gets to equivalencies or identities that need to hold for the typing to be admissible.
Yeah.
Now, that gives the type system a series of equations, right? That forms a system of equations that it needs to solve, right? And it does that by unifying the left-hand side and the right-hand sides, which means that it tries to substitute one of these into for the other one in the next equations at hand, and try to solve the system of equation. That is what is called unification, right? Now, there is an excellent book for hardcore theory people, meaning you, which I read back in 2006. It's by Frank Sparda and the other one, Nitkov, Alexander Nitkov, right? It's called term rewriting and all that.
Oh yes, okay.
That's a beautiful piece of work, but it unfortunately is not accessible to everyone because it's hardcore theory. So unless you have the taste for it, you're not going to enjoy it. But I think that you guys will.
So rewriting is that book is much easier to read than Teresa, which is like the other big term rewriting.
I don't know which book that is.
That's Dutch one.
Qualcomm probably has the book, right?
Both of them are legal.
No, Teresa is in the library. I've had it lent out for half a year.
Right. Okay. But it's a beautiful piece of work. It's not many people can write such a good book.
Yeah, it's much more.
Yeah.
It's very nice.
Yeah. Okay. Now, here's the second question. No, it's just not a good place to do that. Right. Let us now say that let us say that we now remove this first case. Can you guess what the error message to read. Guess what? I mean, I'm guessing that you can guess what the problem is.
Base case.
Yeah, okay. That's right.
It's not fully matched.
Yeah, that's right. So let's see the. So you see, the thing is that with that piece of information that it has, you can also figure out the missing item, right? So if I just do this, I'll get the missing item. The other thing that I can do is that I can.
What does it actually say if you hover over the one?
This is
Yeah, they look covering, yeah.
Yes, yeah. But you know, it has more than that. It can recover, right? Now, I would like to invite you to also consider this case, right? If I say this, then it's all right, because now I have said that, look, this guy doesn't have anything for that specific case, right? Now, there is a game that you can play here. So if I have a function and I specifically say that it's total, right? And I think that it is total, then you know, Idris will actually tell me that you know, whether or not I'm right, it will inform me, right? So it's a good idea that sometimes if you're not quite sure whether that is the case, you just try to enforce totality so that you see whether you have missed anything, right? And of course, you know, this is all Turing complete. So working down to totality is Turing complete. So don't expect that Idris can figure out totality of your function at all possible scenarios, but it's you know, it will help a lot. So now I would like to summarize at this point that there's a workflow in type-driven development in TDD. You work out a type, you ask Idris to create a skeleton view, and then you perform pattern matching on one or more of the arguments, and then you fill the holes either by performing expression searches or refining the holes by hand, right? And this is by hand. And this is the process of type, define, refine, right? Now, Sander, give us your joke, please.
I thought it should come with like a quiz question.
If you wish, yes, but don't expect me to be able to answer that.
General education.
Okay, we'll start.
I'm open to that.
We'll start out with something about where we are.
Okay.
When was the university? Because when was it first founded? When was it established officially?
Late 1800s,
Yeah,
I guess 85.
I'll give you like a hint. When did it become a university?
Oh, like
I
that.
guess-
That would be.
I was guessing
1905.
Someone else.
Yeah. I could go.
Late 18.
Well, that's. I remember how it started. It started as a reading group at the museum. So,
a reading group.
yeah, like I said, people would get together in colloquiums and talk about academic things.
Right.
Yeah.
Okay.
We've come a long way.
Yeah, exactly. Now we're in a room and talking about academic with computers.
Yeah. Okay. Okay.
Okay, so 1911, I would say, we got a shot.
Yeah, and then after we got out of the union,
Which I think that was not 1905.
that was like around.
1905 is when it got up.
Yeah, yeah.
So I remember celebrating the 100 years.
Yeah.
Jubilee,
Oh, okay.
like in
100
2005.
years without Swedes. That's a big deal.
Oh, they're still here.
Yeah.
We can't get enough.
Right. So you guys remember those?
Well, I know they're being liberated, but no.
We were there.
They were there, yeah, of course. It's here.
But I'm pretty sure we celebrated was the establishment of the museum, University Museum,
Right.
which in itself is not a university. Because that was established in I believe it was 1946. I'm double checking. Where it was its own university. Yeah, it was 1946. Before that, you have the University Museum, which was technically like a satellite thing of
Right.
so it didn't actually get established.
Oh, that's.
Everything was where we should be in the museum.
Pretty
We had a lot of scientific work that went on. That nonsense, for instance. Nonsense?
Yeah, I tell them.
It's nonsense.
He
Polar
was-
explorer.
Poets.
Polar explorer.
Yeah, also source of the.
Polar. Polar.
Polar, yes.
Okay, okay.
Yeah. Discovering Northwest Passage. Did like the last one.
Okay, but even though he was doing scientific work, he wasn't in a university.
Well, yeah, he was, but he was here for that.
University Museum.
Was it like an extension of?
Right. Of the Oslo University.
Because then we only had one university.
Right.
But
It kind of makes sense, like, I think in Indiana Jones,
yeah,
I get that he was a professor or something, but like, he was just like stealing things from museums.
He was,
I kind of see how
Yeah,
like,
he's,
not so long ago, that was like an acceptable thing.
one of the
He
British.
to that, he also established the Nazi passport, which was,
Oh, but not Indiana Jones, we're back to.
It's
Right,
Nazi,
okay.
yeah, just Nazi passport was like given for display the.
So that's a real person.
Yeah, yeah.
No, Indiana Jones is not a real person.
So that's why Johnson is a real person.
Nansen is a real
Indiana
person.
Jones is not a real person. He did not establish the Jones passport.
Okay, fun trivia, fun trivia.
Yeah, okay. Right, thank you very much. Now,
everything else like really esoteric, like you have to really know. Here. There aren't like any introductory.
by the way, I think the first university of Iran, there is something that no longer exists, which is called Jondi Shapur. Yeah, that goes back to, I think, 900 years ago.
I think
That's before my time.
Well, before your time.
Yeah.
Okay.
didn't you guys have the first text on algebra? Or it was linked
Oh,
by
yeah,
algebra?
yeah, we have a huge history of scientists, but we didn't have universities, I think until around. I think so. So it is alleged to be the first university in the world, but it doesn't exist any longer. They have recently opened a modern university under that name, but I think that university is so bad that it's actually, ruining yes. But the first modern university of Iran, University of Tehran, which is not the university that I came from. I came from Sharif University of Technology, which is Oxford level. And actually people don't go from Sharif to Oxford and Cambridge and EPFL and ETHZ and all that, because there is this stupid mindset that the American universities are better, so they go to places like Stanford and Berkeley.
This is going on.
Yes, it's so stupid.
If I remember correctly, the institute itself here, it's actually like an offshoot of the Physical Institute.
Oh,
They got a supercomputer and they were like, we need people to like run. So the group like worked up, because a bunch of like mathematicians were like, we have a supercomputer now. Can we like borrow it? And they were like, I guess if you want to like take care of it at the same time, we will.
That's like exactly the same as Oxford. That's
right.
exactly the same.
So computing laboratories. That's why. Well, in Cambridge, it's called computer laboratory for similar reasons.
So you'll see like pictures on the walls here and there of like people with like this. I think it was a ENIAC something.
Yeah.
You know, like if at least in the, you have like a supply closet.
Right.
Like,
A little Polaroid.
then you have like a toilet. And in the break room, you have like something else.
Right. I've seen that one. Yeah.
With the 4 channels.
Yeah.
old school.
So,
bunch
you know,
of
but-
like
but-
and now,
yeah, yeah,
fuck, we're like the largest institute by student amount, I think.
yeah.
Because everyone wants to do IT.
Oh, I didn't know that.
So we have it's a wild amount of students.
It's Joxy.
Oh, well.
Now we get into like, does everyone just want to?
Yeah. Academia, yeah, that'd be great.
I do remember, I used to speak with one professor at Oxford who was, I think he was 98. You couldn't tell, it was quite incredible. It was quite incredible, he was a lecturer of a logic course,
Uh-huh,
but I didn't take that because I did my logic in the philosophy side.
right.
But we used to speak, and he still referred to the place as the lab, because he was one of the people that
The original one.
yeah, it was still the lab.
So I affiliated the Bergen line with the Tyler word.
Yeah.
I don't get a lot, but I'm so mad about that.
Yeah.
I vented my frustration to you on now.
Okay.
And she's like, you can just buy one. And I'm like, no, I want.
It needs to be a university price.
Like, they have that. I just put one for like 400. 40 pounds or
How many
euros.
sounds like it's worth it?
I think that may come out of your 7,000 budget.
I'll have to ask one then.
Right,
What your request.
guys,
Yes.
let's see, so,
Get back to-
just to wrap up. I think University of Tehran is older than that university,
This
but yeah, I have to check that out.
a little bit.
But I was surprised to hear, I was expecting something at least 2-3 centuries. Yeah. Anyway, so now, what is? Oh,
Almost 100 years older, 90 years.
right,
80.
right, let me see. This is not the right function to have put here. Now, we are about to perform insert sort or insertion sort and see how in action TDD can help us on that. And that implies that I should have the right typing. I can do that manually. So, sort, that's going to give me a vector of okay. Now, so what is the first thing to do in TDD? Well, yes, we have done that.
Skeletal definition.
Yes. So I'm gonna add clause here. Next.
Case explicit.
Yes. Next.
We're done.
That's
Fill it out, I guess.
Yeah,
Okay. How do we do that?
with the default.
Refine.
Yeah, that's called refining. That's right. Yes, but what are the techniques for that?
Yeah, look at the cases and fill out the.
You can manually do that. That is
Generates.
visual.
Yeah,
Yeah, you can generate that.
Yeah,
Absolutely. So press search. And you see that the only expression that the search finds is rightfully empty vector, because an empty vector sorted is can only be an empty vector. And well, sorry.
I said crazy. Yeah.
Yeah. So then you can also try things with this one, right? But the thing is that the typing information isn't enough for figuring out what you want to do. Now, here's how we want to do it. So you would want to, so insertion sort works like this, that you pick up the head, you sort the rest, the tail, and then you figure out where to put the head so that it's at the right position, right? So by wanting to do it in this stepwise fashion, you would want to store the sorted amount of the sorted part of the tail at some place and then perform the insertion at the right place, right? Now, here's how you would probably want to do that, right? Okay, so I removed that, right, sorry. Right. Sorry. Stop recording. Okay, so now we have a let expression. We want to perform the sorting on the rest, on the tail, and then do something with what we get, right? Now, here is another beautiful thing about the unfolding of your logic. You would probably want to do something with the results, which is insertion of a thing, right? Which is probably more than just a line of code, right? So you would want to, because that's non-trivial, you would want to give it its own place. Now, here's one thing you can do about that. You can tell Idris that I want to have a separate lemma for this. So take me for granted, please, that I know how to do that in the future. And at this point, just give me something that works, right? Now, if you do that, then you will get this, which says, okay, we have a lemma which, given a string x, a list of strings x's, and another list of strings x's sorted, we'll know how to figure out the job, right? Now, we being people that are educated about the logic of this, we know that we no longer need x's, right? Right? Which means that we should be deleting this way, right? Now, if I save that, then I'm done. Now, to a certain extent. First of all, the naming isn't right, so we know that we usually call this insert. Okay, so let's just rename that. Okay. Save. Let's see what's next. So, would you like to?
Did it again?
No. I'm trying to follow the instructions that I have given myself. This is the way, right. So the thing here is that it's getting a name to the first argument that it receives for insertion. That's and the other thing is that it's my apologies. I missed something here. We want to sorry, can I just make it a question? Do you can you figure out what I was missing when I gave typing to insert?
I think I can.
Please.
Well, did you not name something which meant the name appearance in the lemma?
No,
did you want to do it
it's not a typing error, right?
Yeah.
But your clue lies in the difference between insert, the two versions of insert. And it's not the naming.
Okay, in which case it's that we wanted to do it generically.
That's right. I wanted to have genericity by type because it's a sorting algorithm doesn't just work for strings. It's right. Okay. So that's that, and likewise, we need to do this.
Do you need a requirement that that's?
You go, yes, you're going fast, and we're gonna get to see how Idris automatically figures it out, right?
Okay.
But yeah, but yes, you're right. Yes, you're absolutely right.
We should start over from. Or would the resulting search expression search give us the same? Since we're not no longer, since we're doing generic, yeah, I meant would it still give us the same left text as sorted?
We'll see.
We'll see.
Okay. Now, let me see what instructions I have left myself. Okay. So we just follow the TDD clause. No, that doesn't seem to be good. Sorry, here's by the way a shortcut. So if I do this, then in addition to adding clause, I can get to perform some searches, right? Now okay, I'll add for clause, then I'll perform, so I'll give this a name. So let's say that we want to not at this point. So this one is, and then perform a case split to this, because that's logically insertion, right? And then right now, let's see. In the expression search, it can figure out that this is the only possibility, right? So this one, unfortunately, the expression search can't really help, right? But what you can do is that you know that there is going to be a case split, right? According to the values of the X and Y, right? So what you can ask for it is to say make case, which is different from case split, right? Make case for that home, right? And it gives you a case expression, right? Now, what is going to be the thing that you will make cases, you will case splits according to?
X is less than or equal to Y.
Absolutely. X is less than to Y. Now, as soon as I do that, then this shows off.
Yeah.
Which is the thing that you were picking up. Right. Okay, so that means that I need to say that, oh, wait a moment, this guy needs to be, this 11 type needs to be type board, very thin. Sorry, what was the syntax? This. Right? Now, let's see what this error is. The type of version. Oh, sorry. Now, when I do that, then it reminds me that I have to also, because I have a core on insert here, it implies that insert itself also needs to have that requirement or enforce that requirement. Okay, good. Now. Then. So now we can case split, right? Because the result of x being less than y can only be two things. It's either true or false, right? So we perform case split, and okay, now the expression search becomes a bit fun, but it's still quite interesting. You see, it understands that perhaps some sort of juggling around with the order of x and y should do the job. No. Now, what's the correct one with x being less than y?
Y plus plus insert x y's. I think. Oh,
If x is less than y.
less than y.
Yes.
Okay, then it's
Why is it?
x.
Why is it elements to be used constructed? Why is it elements to be?
Well, what you said had the order wrong, but it was disregarding that. The result would be of the right type, but you were using plus plus,
Yes.
which is more expensive than cons.
Yeah.
Okay. But anyway, I mean, my apologies for being a
No, that's fine.
systems programmer.
That's fine.
Oh, the same one.
Yeah. Okay. So I'm going to jump for it. It's this, and then save. And this time, which one? Yeah.
Y cons x. Sorry, yes.
Yes. Absolutely. That's right. Thank you for yawning. Yeah. It reminds me of the time for another joke. Let me see whether there is anything.
Yeah,
Yeah,
I was going to say it needs to recurse.
Yeah.
Insert. So wasn't it like completely? No, just inefficient.
Right. Okay. Then correct me.
Insert
Correct the first.
Wait, so I need to think about.
Okay. Well, I just copy paste. It doesn't.
Yeah.
That's not really.
Oh, it's on both. Okay.
No.
Yeah, y cons inserts x y's. Yeah.
Yeah.
I'll just copy paste. Okay. Then you give it a string. Sorry, a list, and it sorts it for you. It's on you to check them. Now, yeah. Oh, by the way, any questions?
I have one question,
Please.
and that is, so in Haskell,
Yeah.
type classes are of kind constraint,
Yes.
whereas here, ord ln is of type. And so I wondered how the mechanism of the, I just wanted to actually what it does.
Order is given as a record, in a sense, but a record order types. And then it has to fulfill the record is a quantification, right?
Yeah.
And then it has to fulfill certain conditions, such as having a less than. That's like implemented.
And that's how type classes and interfaces become different.
Okay, so
you'll see part of that in the section that in the chapter that we have on disk types.
yeah.
And another part of it, if I manage to, in the if I'm about to teach you interfaces and all that, I will need to change the C++ curriculum accordingly, because there are you can do similar things in C++ template metaprogramming. But because I intend not to do that at the moment, I'm probably not going to teach you interfaces, or at least not much of it. But anyway, I think that what Jan told you is mostly correct. right?
Yes, yeah,
I think your question will be answered as we go through those two charts.
Okay.
But quickly put, there are two important factors that make this doable. One is that the difference between Haskell type classes and Idris interfaces. The other is that in Idris types are first class values.
Yeah. Yeah, I see that. It's more, it seems to behave like a constraint.
Yes.
So I understand the implementation. It's more like the fat arrow.
Correct.
What is that thing doing? Because you have a type on both sides.
Right.
And so is there some kind of, I don't know, satisfaction or unification going on?
Yes. Yes, absolutely.
So can I, on the other side, on the left-hand side, can I add arbitrary expressions that resolve to type to make?
Result to type or result to constraints to type?
Well, type, because the type of board is type to type.
Right, well,
So if I wanted to express on the type level that this output vector is sorted.
right, don't know.
Okay. It's possible. I know it's possible because it's dependent.
Yeah,
but it's
yes, but I don't know how to do that.
Okay.
I have to be honest with you.
Because I know we can do that in refinement typing.
Right,
We can do that kind of thing.
Right.
Yeah, refinement typing.
yeah, that should be doable, but I don't know how to do this.
Yep.
But yeah, thank you very much for asking that question. It's this kind of development is a part of what will definitely blow the minds of C++ people. If you just show them that you can claim that you can enforce it at compile time, that this is
They were very hostile to the whole strong concepts thing.
well, no, if you speak their language, they will not.
Okay. I don't know how to pronounce colons.
The thing is that it's if you tell them, if you show them C++ that does this, they will begin to worship.
I think it has a bit, I think, maybe.
But if you tell them that I have this Idris which does the job, then
But the committee already rejected like the strong concepts.
this is not a concept.
this is different, this is.
Oh, yeah, sorry.
Types only have substitutions.
Okay.
This is lightweight concepts, you know,
Yeah.
it's not that much of a heavyweight concept. Yeah. Now,
Category of families.
with actually there is kind information in that too, in addition.
Oh, yeah.
So it's not just family polymorphism as we go.
Also, but it's families of families of families.
Right.
Yeah, sorry.
There's kind information. Yeah, anyway, but you shouldn't say that to C++ people.
No,
You know, you say family polymorphism, kind type,
yeah.
high level programming. Yeah, okay, we're done with this. Now, Jan should now tell us his joke.
Okay, so why didn't the moose want to go into the lake?
The moose didn't want to go to the lake.
That night? Because it didn't want to be a reindeer.
It didn't want to
Become a reindeer.
a reindeer.
Yes.
Oh,
Because
okay.
it's a pun on the word line, which is here in Norwegian.
Okay.
That's like the joke.
Oh, this is. I should.
You asked for Norwegian jokes.
Right, but you should have, I mean, you should please explain more of the terminology involved. I realize that there is something about the words here.
So, clean in Norwegian is rein. Rein. Oh yeah, rein. Maybe that's my dialect is very uncultured. So I'm gonna say we use the spell back instead of the rolling call. But yeah, rein means clean, but it also means reindeer.
Oh,
Yeah,
okay.
or deer. So,
Okay,
It's like one of those shows like two hunters meet, then they both die.
In German joke.
Yeah, it also works in Norwegian, two jägare träffar varandra at the back. It's and yeah,
okay,
so it's two hunters. hits
double
each other.
entendre.
They both die because they shoot.
right,
Yeah.
okay.
But yeah,
Right, but then you have to have the exact words so that you
Yeah.
understand it.
but it,
But the second level tuber is translated. And then-
Oh, that becomes very difficult, yeah, I have tried that, and, you know, I'm very picky about translation, right?
But also to translate it badly, because that's what makes it funny.
Actually, you have to translate it very well in order to make it funny in the target language, and not
Depends
all.
who you're trying to make laugh.
Okay.
I'm just not a person that finds it very funny, but it's and I guess unintentional.
Sure, we had a very good presentation of that today. Right, guys, there is a section on TDD with matrices. You should do that yourself, right? Each of you, please do that yourselves. And please do not copy paste. I did that once, but please do not copy paste. Because it will, you know, it will really make you experience type PDB. The other thing is that, okay, there is a bit of a trailing piece of information here. Now, let us suppose, and this is going to take only a few minutes, let us suppose that I want to, instead of recursively working out the length of a vector, I want to use this piece of information. If I, instead of doing things this way, I do do this, it will cry at me. Does any of you have any guess of why that is happening?
I believe that the syntax that you had, that you've commented out, in the curly braces,
Yeah.
you can essentially pull some type information from the rest of the expression into the argument list.
Correct. So the thing is that the n that is upstairs on line 6 in the typing information is a part of the typing information, which is not normally around, right, at the expression level. And in order to pull that into the expression level, you have to go with the syntax that I have just commented out. And in exactly the same fashion, if I were about to, you know, and this is a function that you will be using in the matrices, okay? If I wanted to do the you know, n copies of empty lists, this would have been the syntax. And the new thing here is that I can k-split on the type level n in pretty much the same way that I can do for the so let's say that we didn't know about this. This.
Because it doesn't know it's mapped yet.
Should, yeah, this should, but I prefer it.
Well, let me. Paste the previous time, but But let's try what you just said.
There's no element.
It doesn't know?
Element.
I don't think it needs to know. so
No, it shouldn't, it shouldn't.
Okay, maybe you need to put the n in and then they split on the n. On line 7.
Yeah, I mean, let's see what we get. Oh, no, okay. Okay, you're right. Okay, now, again, this will find the right. So this will find.
Why is the pattern match syntax different?
Well, because now you're essentially forming pattern matching on entities from the type level.
Yeah, I just wondered why it wasn't. It maybe could, but probably not because they haven't. Made it so that you just had to put a 0 in curly braces and then in curly braces SK.
Ah,
I keep the curly braces. but I
right.
think-
I don't know. I don't know.
In Active, these are hidden, so
This
they
is-
can you can like either instantiate them with the curly brackets
Uh-huh.
here, or you can keep them as just like infer, sort of like the background. So maybe if you take away the curly brackets, this might still work.
No, I know
No,
that one will
But that
not
one
work.
won't work,
No.
okay.
But
That's- then
the
I
thing is
understand.
that I haven't tried it, maybe.
Or
this
maybe
works.
just bracket without curly brackets.
I just don't know.
Maybe this works.
That shouldn't really, no.
But why? Why do you have to have the n equals?
Well, try it with the brackets around, just regular round brackets around that.
Around, no, that's I know it's not that.
Yes,
No.
Guess you can have more.
Could be, but the thing is that you.
You basically buying.
Yeah, you bind them to that value.
Yeah.
That's-
Right, but you see, this is the technical difference between type level values and variable level or ordinary level variables is that you know these are erased at runtime and you're essentially
Oh, is it to make it explicit that it's not being erased?
yes, you are instructing Idris not to perform that erasure for this very case.
Okay.
Right? But still, I believe I'm not 100% sure about this, but I think that even what I just said is not exactly right. What it is saying is that I have to do business with the compile time piece of information after the usual erasure, but still we are still at compile time when we are performing this case fix right now, which is the reason why you need the curlies around, right? Because this is anyway not going to make it to the runtime, right? Yeah. Okay, good. That's it. That should be our session today. Or do we have any questions?